Click the bell icon to get latest videos from Ekeeda.
Hello friends, so in this video we are going to study about the magnetostatic deflection of electrons. This means we are actually going to study what is the deflection that is produced by a particular magnetic field. Let us understand the situation with the help of a simple diagram. We have a region of a uniform magnetic field, and the magnetic field of course is directed in a direction which is inside the plane of the paper, and the electron is injected with a particular velocity out over here, that is v0, or for simplification just v, and it will undergo under the influence of the magnetic field. The magnetic field will act upon this. There will be no change in the magnitude of the velocity, but the direction of the velocity is going to change, and due to that it will happen that it will actually trace out a small arc, which is the arc of a circular path. Had this been spread over a larger area, the electron would have got an opportunity to complete a circle, but in this case, depending upon the magnitude of the velocity, we are having only a small arc that is traced in the given area of the magnetic field. So after it emerges out from the magnetic field, it will trace out a path, and ultimately it will strike a screen at a distance d from the magnetic field, and it will strike the screen at a distance y. L is the length of the magnetic field. So from the geometry we can say that tan of angle theta is going to be equal to y upon d. Let us say that this is expression 1. Similarly, you can also say that your tan of theta is equal to the opposite side, which is going to be L divided by R. We can now equate these two together, and you can say that y upon d is equal to L upon R, and thus your deflection, that is the y, is equal to d into L divided by R. R is nothing but the radius of that particular circle which this arc is a part of. So the radius expression, we know that R is equal to mv upon eb. I substitute this expression over here, and this will be equal to d into L into E into B divided by m into v, wherein d is the distance of the magnetic field from the screen, L is nothing but the length of the magnetic field, E is the charge on the electron, B is the magnetic field intensity, m is the mass of the electron, and v is the velocity with which the electron has entered this magnetic field. Thus your y will be given by B L E D divided by m into v. But we also know that the velocity v is given by the expression 2e into va, this is the voltage, divided by m. So the velocity which the electron acquires whenever it is accelerated through potential difference of va. So I make this substitution over here, and then I get an expression for y. So the expression for y is equal to B L E D divided by m into square root of 2 into E into VA upon m, and therefore your y is going to be equal to B L E D into square root of, when I take this inside, this will become m square, so therefore this is going to be equal to, hence this expression will be equal to, when I take this, I will take this m over here, this will be equal to m upon 2e into VA, and therefore your y is going to be equal to BLD into square root of, this will become m into e square divided by 2 into e into m square into VA, and therefore these parameters will cancel off, and your final expression for the deflection, y is equal to BLD into square root of e upon 2m into VA. So this is the final expression for the deflection. Now if I want the deflection sensitivity, and the deflection sensitivity, let us say, is going to be given by S, which is equal to y divided by b, then this is going to be equal to L into d into square root of e upon 2m into VA. The deflection factor is equal to 1 upon AS is equal to 1 upon L into d into square root of 2m VA upon A. So this is your expression for the deflection factor. So we have obtained the expression for the deflection y, then we have obtained the expression for the deflection sensitivity, and we have also obtained an expression for the deflection factor. And we have also obtained an expression for the deflection factor. Sincere thanks, students, for watching this particular video. Stay tuned to Ekeeda and do subscribe to Ekeeda. Thanks a lot.